Hey guys, in this new tutorial we're going to be covering the Redshift State node, and it's a pretty, what's the word, mysterious kind of a node to a lot of people. A lot of people don't really know what it's for or what it can do, and it's a utility node that can provide a lot of uses because it generates data based on your camera position or the objects, and so it's pretty powerful, but it's a utility node. And so a lot of people don't know what it does or what it's for. So I'm going to go over one of the techniques that you could use it for. And so it covers something that a lot of people ask about, is how do I get, for example, slope or shading. Like, let's say I wanted snow on a terrain or on objects. How do I do that? And so this is actually what the Redshift State node is for. It can solve those type of situations. And before I get started, though, I want to say thanks to everybody that's supporting my Patreon. If you guys don't know, go check that out. It should be linked in my YouTube channel. And for everybody else, please subscribe. You know, I make some of these tutorials for the community. These are relatively short, but I want to hear what you guys want to see more of. And so yeah, this was actually something that was asked about in the Facebook Redshift group. And I kind of quickly went over it, but I figured it was time that I made a video about this since a lot of people ask. The technique is basically the same in Maya as it is in Houdini and Cinema 4D. I'll mention where it's a little different when we get to it. And so yeah, let's get started. Right now we just basically have some simple objects, just a sphere, a torus, what looks like a terrain, and just another polyhedron shape, and just a HDR, nothing fancy, you know, and it's just a basic Redshift material right now. So there's nothing really going on, and I want to keep it as simple as possible. You guys could obviously, when you make it yourselves, you'll be layering your textures and doing all kinds of stuff. But for now, I want to just keep the shader as simple as possible to explain the principle. And so before we get rolling, the first thing we're going to do is, so you can see the difference between what the Redshift State node is going to be doing, we're going to actually use a color layer. So let's drop down a color layer node, and this will just let me layer up everything. And so we'll just drop this into our color slot. So we'll plop it in there. And right now our base layer is black. That's fine. And so let's say we wanted snow or something on the tops of this, right? And so right now, if we were to layer it just pure white, it covers the entire surface of the object. And so some people were saying, well, how would I do, you know, how would I procedurally have it only on depending on the slope or angle of objects, right? And so some people tried to use the curvature node or other nodes, and really it'll kind of work doing those techniques, but the Redshift State node is basically what you need. And so if we start typing in state, you'll get the Redshift State. And so this node has quite a lot of features to it. And actually, I'm going to drag down the window for Maya, just because you guys don't really need to see the timeline anyways, and it's taking up space. So you guys can see a little better what's going on in the shader setup. And so the Redshift State node, it has a bunch of outputs: bitangent, out bump normal, out normal, ray direction, etc., etc., and the UV coordinates and stuff. And I'll go over what the UV coordinates for a custom AOV setup, since some people have asked about that also. And this node can spit out data either in world, object, or camera space. And so I'll flip through these once we have it set up so you guys can kind of see the difference. And so what we want is essentially the Y direction, right? Since we want snow falls from the sky, so we want the Y direction. So if we were to just, for example, plug this in directly into our surface shader, so our out normal, we just plug this in, what you would see is the normal, like a normal map. And so we've got green, RGB basically. And so if we come in here and check our pixel in the new Redshift render view, our pixel information, and we drag on over this red or something, you'll notice that the values that as I slide around, there's negative numbers in there. And the reason is because this data comes in both negative and positive values. And so other engines like V-Ray, for example, the normal data and UV data would come in just 0 to 1 space. And so what you need to do now is we need to actually remap this data so that it'll work for our purposes and back into 0 to 1 space instead of negative values. And so this is one of the things that in Maya we could just do this easily. When we're extracting this data, we just plug it in directly because we get the R, G, and B channels. If you're in Cinema 4D or Houdini, you're going to need to use a color splitter. But first we need to remap this. And so again, if you're in the other apps that have the Redshift math nodes, you could just use the Redshift remap node, and that'll remap the values. For Maya users, which is what we're in right now, you need to use the set range node. I'm hoping that in the future all the apps share the same math node, so that way I don't have to explain this, so that people at one tutorial will make sense to everybody. But so the set range node, we're going to plug in our normal, and we're going to plug this into our value. And so this value now is reading in, and we have our old min, our old max. And the thing is, since this is negative, we need to make this -1, -1, -1, 1, 1, 1. And so what's happening is we're going to remap the -1 to 1 back to 0 to 1. And so what this does is it fits our -1 to 1 back to 0 to 1 space. So if I plug this in, and let's just save this, into our surface, we'll get this. And so if you're a V-Ray user, you might recognize this a lot more. This is what a normal map output looks like. And so this now is in 0 to 1 space, so we could actually work with this as color data. And okay, cool. So now our next step is, what we want is we actually only want one color direction. So if you guys know, normal maps, they're split into XYZ, and so RGB. So we want the Y data, the up and down, so that's G out of the RGB XYZ. So in here, and for us Maya users, you just click on the out value and you'll have the Y, and you can just pull this out. If you're in Cinema 4D, again, you're going to have to use a different node. You're going to have to use a color splitter or a float to vector, and this will let you split the float in single value into 3 values. And so we don't have to do that, luckily, if you're in Maya. All we have to do now is plug it into a ramp. So what we're going to do next is make a ramp, and we're going to just plug this in to our Y, which is our up and down, into our V, and we're going to plug this in then into our surface, just so you can see what's going on. And so now it's all white. Now if we start sliding this over, you'll notice that's what's happening. Our slope, basically, as you can see. Pretty neat. And so as you slide this over, you're able to basically control the angle of slope that this lands on. And now this is controlled several ways in the Redshift State node. There's world space, so right now it's irrelevant where the object is. If I spin the torus around, it's gonna land on Y direction. Now if we do it by object space, it's relative to the transformations of the object. So now if I spin that same torus, it sticks to what would be the y normal of the object. For our purposes, we're going to use world space. And there's also camera space, which is relative to the angle we're viewing the object. But again, for our purposes, world space is what we want. And so now that we've got this going on, the object is relatively good to go. This object right here, actually, the angle for it isn't steep enough, I guess. There we go. To actually land on the top. So we have to make sure that your objects have a y direction angle that'll actually work with the ramp you currently have. And so, cool. Let's use this now to actually mask, add a mask layer onto our color layer. So we'll plug this back in. So it's an RS material. And we'll make this color, let's make the base color like a green or something. And we'll plug this into our mask. And so there you go. Now we've basically got somewhat of like a snow layout based on the slope angle, and we can control that using our ramp. And now let's say you wanted to, I don't know, you wanted to control the height of this. So let's say you like it, but you don't want it on the bottom or something, like on the flatter areas. And again, this is where the state node comes in handy. So if we move this up, let's move this over this way. So what we could do is, let's move our state node to the side. We'll use another property. So this time we're going to use ray position. And let's drop, again, this data is has negative numbers, so we have to use another set range. So we could actually just copy this, paste it. And let's just get rid of this so we don't have to use two of them. And we're going to pull out a ray position as a value. And we actually want to make another ramp. Or I'll just copy this one again. Let's delete both of those. And we want the y value because it's going to be the height. So we'll pull in that into the V. And before we actually layer it back onto this color layer, even though, well, there's several, we could layer it as a second layer here on top of the base, but we're going to just use a multiply math node. And so if you're in another application, you'll be using the Redshift multiply. And so let's use the multiply. We're going to plug this into input 1, the out color actually, and we're going to use the out color onto 2. And before we actually connect that in, just so you guys could see kind of what's happening, if I plug this in, you'll notice that we get this kind of weird looking pattern. And so directly in the surface shader, and so it's not a height mask really yet, right? Let's actually let's reset this so you can kind of see what's happening. So it's just a regular ramp. So what we want this to do is actually be black at the bottom, and then as we raise it, the black value up, it increases. But right now it's repeating. And so the reason for that is, again, because of the negative values, but also because pretty much the ray needs to know the distance, the height we want it to go. And so right now we don't know the y height of our object. So if we come in here and you could either make a new locator. So if you just go up to create and make a locator, I already have one. And so it's around the height in my scene that I think I want everything at roughly. And so the transform, the coordinates on this right now are 32. And so if we come over here and we go to our set range node, we have to now tell this the X and the Z don't really matter since we're not using that data anyways. We're only using the Y. And so what we're going to do is we're going to set this to 0. And the number that we have our locator at, right now it's at 32. We estimate that's the height. We could increase it a little more. Let's just say 34 is about as high as our assets go. And so in here, in our old min and old max, we're going to type in 34. Let's see what happens. And so we're a little short. If you could see, the sphere is a little higher. So let's try 36. And now the sphere and the polyhedra and the torus and our terrain is mapped. And so obviously if you wanted, you could use an expression and have wherever this locator is control this value, but you know, we're just eyeballing it. This is just quick. And cool. Now we've got that under control. And so now if we look around, we've got this height data. And so now what we need to do is this same data, we're multiplying it with the slope data. And so if we plug this in now, this is what we get. So it's not as what's the word, pronounced. So if I go like this, let's just say we could bring it down. This lets you have the slope control on the sides of the cliffs, for example. And then this lets you control where you want it. So let's say you only want it on the tops, on the peaks or something. And let's move this over. So now it's only affecting objects at that height, and it's giving us slope control. So if we want, we could do that. Pretty neat. And then obviously we can now plug this in as a mask in here, and let's just get the one channel data, and then let's plug that back into our surface shader. And there you go. So now we're getting slope control and height control of where our shader mask is happening. And so you could, as you guys can imagine, you could just start layering stuff up using the RS state. Now, something to keep in mind, there's two normal outputs. So there's out normal and then there's out bump normal. Out normal assumes the direction of the normals before, if you had a bump map or something, or a normal map, it's before that. Now if you add the bump out, that will compute the data based on the normal and bump map direction changes. So actually, maybe we could quickly just give you guys an example of that. Let's drop a noise, a redshift noise, and we'll plug that into our bump. Let's drop a bump map, a redshift bump. We'll plug that in, and then we'll plug it into our bump map. And oops, this is actually supposed to be an input, not scale. Let's see. There we go. And let's increase our scale, just something to exaggerate the bump so you could see it in here. So it's pretty exaggerated in strength, and let's make it a little bigger. So under coordinates on our noise, let's try 2 and yeah. So as you can see, there's bump all over our example now if we come in here. And so what the difference is, the state node, if you're just using out normal, it's not going to take into account the bump data. It's just going to do it based on the geometry itself. So if we were to actually export with the out bump normal version, it's going to take that into account, and obviously it just totally messed this up because it's being influenced by the bump normal. Oops. It's being influenced by the bump normal attribute. That was my mistake right there. It's actually supposed to be right positioned. So if let me see if I could do a little screenshot comparison and do an out normal. And let's zoom in here. Huh. It's not doing what it's supposed to be doing. That's kind of weird. Well, that's odd. But yeah, that's what this is supposed to be doing. It's supposed to be giving you the bump output before the normal direction output before it's influenced by bump, and then regular. And so anyways, let's decrease this. And why is it not? Previewing. Okay, I had to pause that for a second. There was some sort of weird render view bug. But anyways, let's get back to that. Where were we? And now for some reason the hyper shade's not. There we go. Okay. So anyways, where were we? Yeah, the bump. So I'm just going to leave a little bit of bump on this. Let's turn IPR back on. And just do 0.4 for now. And so let's say you wanted to introduce a little bit of noise or something in here to kind of break up those edges. You could do that too, just using pretty much the same old thing that we're doing right now. You could either multiply or using one of these again. So let's say, I don't know, let's bring in a noise again. And another multiply. And we plug that in. We'll be getting now these noise values. And actually, let's use a ramp again to control the noise. So let's delete that. Let's plug that in to there. And this will just give our noise some more contrast. And so you could see the noise kind of in there, but Let's actually disable the bump for now, just so you can see it a little better. Right now the noise is too small, so let's, I don't know, yeah, that's decent scale. And let's make it less harsh. Of course, you could invert it, you could mess around with the values, you could tweak the noise type. And yeah, you guys kind of get the idea. So as a quick example, I decided to quickly just get an actual terrain model and apply those techniques that I just mentioned. So right now, if we zoom in, we've got, you know, a bunch of variations on the surface of this terrain, and it's all being procedurally controlled and generated using the techniques we just mentioned. And so the Redshift State is giving us our slope and our rate position, and that's what's allowing us to adjust our ramp. For example, our color layer, our base color, is all actually made with a ramp that's controlled by the I thought it was being controlled by rate position, but right now it's actually slope. So if I actually plug this in down here, I believe, let me oh no, should be this one up here actually. If I plug this in down here, it'll give us a totally different look. And let's just test it out. So we'll get the Y. And yeah, so that's our ramp. This color ramp. So if I move this down, our colors will change at the bottom based on the height, basically. The higher things are, see, now there's more green down here and stuff. And so that's controlling our color ramp based on height. I actually think it looks better with slope, so let's actually move that back to using the slope. And that's giving us this. It's a little more chaotic. And then we've got, so this ramp is being controlled that way. And that's our base layer. And then our layer, our snow layer on top, is then being controlled like I showed you guys earlier. So if I move this down, we'll get the that snow further down. If I move it up, it'll end up where it ends up based on height. So if I lower it all the way, we're essentially getting snow all the way to the bottom. And if I move this up, it's only on the top most layers. As you can see. And then we're controlling the slope using this ramp. So if we want snow everywhere, just do that. You see. So yeah, this gives you quite a bit of control. And so, like I said, the techniques that I showed you guys on the basic shapes, it's the same thing. It all translates over. So if you have some interesting geometry that's got a lot of variations and changes in shape and slope, angle, and stuff, you get some pretty cool results really easily. Just adjusting this based on slope and whatnot. So you can see all the neat patterns we're getting out of this. And so yeah, you know, you guys just throw in an atmosphere or something, and like we have right now, and you get a pretty good sense of scale and whatnot. And so, you know, we could increase the attenuation on this, so there's more atmosphere. .5, that might be too much. 0.3, 0.45. No, let's go with 0.25. 0.2. 0.2 looks pretty good. And yeah, I think you guys kind of get a good idea of what's going on, and some of the cool stuff you guys can do. See? And so yeah, so hopefully this gives you guys a good idea of kind of what results you can get, you know, just using this technique. I'll actually be uploading this file and the texture and HDR for everybody to see how it works and check it out themselves, and it'll be on my Patreon. I'll just have it there for free for anyone that wants to try this out. But yeah, hopefully you guys learned something pretty cool, and thanks again everybody that's supporting my Patreon. Really appreciate it. I can continue to make really cool tutorials for you guys, and free tutorials like this one, so hopefully you guys can learn some new stuff. Please feel free to ask any questions, or if you have any requests for something specific, I could try to squeeze in some time and make it. And yeah, subscribe to my YouTube channel and sign up for my Patreon if you guys can. Thanks again for all the support, and have a great day.